Hey Calculus, we are here. We are ready for section 2.2, and so here we go. Last section we just dealt with, the rate of change is basically the equivalent of the slope. And what we're going to look at today is what is called the limit, or actually in this whole series. Section 2.2 deals with the limit. And the limit is basically asking what value, specifically what y value, are we approaching as we get closer and closer and closer to the stated x value. And even if that x value, or at that x, if we don't have a true y value, it doesn't matter. We're looking at where are we leading towards. And so if we look at example number 1, and here's the thing about limits. We really need to look at it from both directions. So if we look at number 1, it says the limit as x approaches 0 of f of x. And this will be one time that I'm going to actually draw a rough sketch of the graph. Now when we come from the left, x equals 0 is right here, okay? Anywhere along the y-axis. So we're going along, and then we start to go up. The y value seems to be going up and up and up. Then all of a sudden it seems to be heading towards the value of 0. Likewise, if we're coming from the right, we're going along, we're traveling along, and then all of a sudden it rises up, but then it drops dramatically, so that as we get closer and closer to x equaling 0, we see that the y value is getting closer and closer to 0 as well. So the question becomes, what is the limit here? Well, the limit simply is 0. The limit is asking, where are we heading towards? Even if this value doesn't make sense, we are heading towards 0. Now, if you look at number 2, from the left side, it appears to be going straight down all the way up, or all the way until we hit the y value of -2. Going from the right side and going towards x equals 0, we're going towards x approaching 0. Even from the right side, it seems to be -2. So the answer is -2. Now there are many ways to find the limit, and we're going to look at several. And I'm going to be just cramming this into as short of time as I can, but realize that it's going to be a whole lot of stuff. We'll get to work on it, okay? So number 3, what is the limit as x approaches 0 of x squared minus 5? Now one of the easiest ways to find limit is by substitution. We're saying x approaches 0. Okay, it gets closer and closer to 0. Let's try this. Let's just plug in 0 in for x here and see what we get. 0 squared minus 5 equals 0 minus 5, which equals -5. And that's the answer. As long as it is a legitimate answer, 90% of the time, then that is our answer. We will look at some exceptions to that rule here shortly. Okay, let's go on to example number 4, which falls under the same category. The limit as x approaches 3 of the square root of x squared plus 10x plus 25. Well, let's just try substitution. If substitution works, great. If it doesn't, we have to try something else, and that's what we're going to get to eventually. But let's just try this. Okay, the square root of 3 squared plus 10 times 3 plus 25. This equals the square root of 9 plus 30 plus 25. 9 plus 30 plus 25 equals 64. Square root of 64 equals 8. And so what is the limit as x approaches 3 of the square root of x squared plus 10x plus 25? It equals 8. And if we would actually graph the square root of x squared plus 10x plus 25 and see where does it approach when it's getting really close to x equaling 3, we would get the value of 8. Now sometimes value or limits don't necessarily exist. I'm not saying that's what's going to happen in this next section, but it certainly could. Let's look at this one. What is the limit as x approaches negative 13 of 29 minus 4x? First thing we're going to do, we're going to try substitution. So we get 29 minus 4 times negative 13, which equals 29 plus 52, which equals 81. So what is the limit as x approaches negative 13 of 29 minus 4x? 81. The big rule is if you don't break any rules of arithmetic or mathematics, you're probably fairly good to go. So let's look at what is the limit as x approaches 256 of x to the 3/4 power. Let's try substitution. 256 raised to the 3/4 power equals exactly 64. So we're saying if we would graph x to the 3/4 and go all the way out to where x equals 256, it would be getting closer and closer to the number 64. Now we have 5 problems in the next one, which asks, find the limit if it exists. And here's situations where it may not exist, and we will talk about those when the time comes. We begin with the limit as x approaches 1 of 2x minus 7 over 4x plus 5. Let's try substitution and see what we get. Plugging in 1 for x, we get 2 times 1 minus 7 over 4 times 1 plus 5. This is 2 minus 7 over 4 plus 5, which equals negative 5 over 9. And this is a legitimate answer, so I would venture a guess this is the correct one. As long as the arithmetic is correct, we're good to go. Final answer, negative 5/9. Carrying on. Example number 8. Number 8, we're asking what is the limit as h approaches 0 of 2 over the square root of 3h plus 4 plus 2. Let's just try substitution. There is nothing special about this being x or h. It doesn't really matter because as long as it's a variable, we're approaching the independent variable. It's getting closer and closer to 0. So let's try substitution. 2 over 3 times 0 plus 4 plus 2. And so this would equal 2 over 0 plus 4, the square root of it. And that would equal 2 over the square root of 4 plus 2, which equals 2 over 2 plus 2, which equals 2 over 4, which equals 1/2. And so the limit as h approaches 0 of this is 1/2. And so far we have not run into a problem where it does not exist. We will look at that situation, guaranteed, in the next video.